So a capacitor has a positive and a negative plate, and the electric fields always point towards the negative side, and obviously the charges are going to go towards their opposite. So the positive is going to go towards the negative, and the negative towards the positive side. That's, in terms of capacitors themselves, that's all you really need to know. But then in circuits, they get a bit more complicated. So, yeah, so this positive is going to go into that negative, and the capacitors are slowly going to get charged over time. It's not really that slow, but for a series circuit, which is this case, you can calculate total capacitance similar to total resistance, except it's the opposite. The total is equal to what it would be for a parallel in series, a parallel resistor. So it would be, in this case, 1 over C1 plus 1 over C2 to the negative 1, which when comparing to the resistor, it would just be R1 plus R2. So this is basically the opposite of the equation for resistors. And then we can just like add another one. Okay, yeah, so these just two dashes are the capacitors. And then to calculate the total capacitance in a parallel, then you would just do the capacitors themselves, which in this case would just be C1 plus C3. I mean, what else?
Where does the C2 come in for parallels, or did it just not?
Well, C2
No, it's just
not
the total parallel. This is the parallel circuit. That's part of the series.
Oh, okay.
This is just for the parallel. So I guess you should just put parallel instead of EQ.
But okay, for let's say that the whole for the entire circuit.
Yeah.
Would you then do like
exactly?
What?
So CEQ would then be equal to, so
you add
C2 plus. Wait. Yeah.
No.
No. Wait a minute.
You got this.
Hold on. Okay. This once you do this would just like combine to one, right?
Yes.
Like in
Yeah.
resistors.
Yeah. That's the same. Yeah.
So then let's say replace this with this. That would be C2 plus this, or would it be like this?
It would
Which
be
1 over C2 plus 1 over this.
C2 is parallel to these two combined. So once you add these together, then you have to use this formula because they're now in series with each other.
It would become a series circuit. You can combine these two, and then you can turn it into a total series circuit, which you can then just do this. So then it would be 1 over C2 plus 1 over the total of C1 plus C3.
So minus 1.
Yeah, that goes the same with resistors. If you have like a parallel part, you can combine them. You can add them to get the total of the parallel, and then turn that into a series, which just makes it a lot easier to find the complete total. So this FRQ was, Carter got it pretty well. I screwed it up, but eventually I got it. You got this. So part A is just to calculate the total current of the battery.
Gotta get a better handwriting.
Oh my god, that plus side is like completely diagonal. Okay. So
have to
calculate the total current. Yeah. Each of those resistors 1, 2, 3, and 4 are all 10 ohms.
1, 2, 3, 4.
They're all 10 ohms.
Okay. Question.
Yup.
Since technically these are all parallel, right? Would I
No.
To each other.
Alright?
Look at the 2 ohm resistor.
Does that change? What does that change?
That's a great question.
Okay, so at least these two are.
Okay, yeah, that's a good.
How does? Well, why isn't this one? Just because of this? But like, what? Like, sure, it's because of this, but why does that change that?
Okay, well, you got the important part that 3 and 4 are parallel. So what would you do with it, using that?
Well, these are resistors, right?
Yeah.
So, what's this symbol for it? The variable?
Ohms.
That's the
R.
This is the units.
R.
R. Okay. R for parallel. Parallel, which would be for these two,
Yeah.
which is 3. And
You can
4.
have the reference table. Do you have the reference table?
Somewhere.
So this would be 1 over
It's doing good.
is 10.
10 ohms. They're both 10 ohms. Yeah.
10, and then plus 1 over 10 ohms. This is to the negative 1.
To the -1.
Yep. So this would be 2,
Something.
5.
5.
This would equal parallel 3 and 4, which equals 5 ohms. Yeah.
Ohms. Okay, so now you can redraw it.
I would suggest redrawing it.
Yeah, definitely redraw it.
Okay. Where's the eraser?
No, don't just get rid of it. Just redraw a smaller one somewhere else.
Oh.
You're gonna need it.
Yeah.
Okay. Let's come and answer. Okay. So let's try here. That was
Good enough.
that. There's this here. This is what, 2? Which is 10 ohms. Then there's this one. One, which is 10 ohms as well. And then this gets reduced to this, which is 5 ohms. I mean, yeah, 5 ohms. Right?
Yep.
I'll just name this 3. 5 ohms.
3 plus 4.
Sure. Let's do that. 3 plus 4. Looks like that. Alright. There. Now, you said these two, so, are in parallel because of this. So what would I do then?
Exactly.
Well,
What's the other type of circuit?
in series,
Okay.
which would just be, but
Look at your redrawn one. Are is any of those in series?
well, these.
Okay.
But then what do I do with this? Okay. Our series, which is 2 plus 3 plus 4, is 10 plus 5. Yeah. 10 ohms plus 5 ohms, right? Is this correct? Okay. Your silence is rocketing. Alright, and then that's 15 ohms. Let's redraw this. Wait, where would I... Do I redraw that? Because yeah, I mean combine that, but where would I put that? Where would I put this, in that thing?
It's a great question.
Figure it out.
No, let's say here, is that okay?
Is it?
Because then that would allow for the parallel of this. Would it?
Would it?
It's not helping, Carter. Alright, let's put it there for now.
Okay, if the answer comes out to an even number, you know you did it well.
Is it even?
I don't even remember.
This is 1, which is 10, and then this is 15, which is 2 plus 3 plus 4, so 15. Now, parallel of that.
You dropped something.
Ugh, I didn't drop it, I hit it, and then it fell.
I don't know where. Where's mine?
Alright, this parallel. R parallel of 1 plus 2 plus 3 plus 4 equals.
You need to write that.
Parallel is 1 over 10 plus 1 over 15 ohms to the -1, which is
that's kind of annoying. Dude, you're calculating?
No, it's not. He's got it. It's not. It's an even number.
Alright.
That's annoying. Then give him a calculator.
Last time shoot times 3.
Where's the calculator?
We don't need a calculator.
35. 1 over 5. Wait, no. 30 over 5, so 6.
Yeah.
6 ohms. So, wouldn't that be the
Total resistance.
That's the absolute total. But now you gotta get
Oh,
current.
how do you find the current? Shoot.
V equals IR.
V equals IR. It's total resistance.
Yep.
So, V equals IR, you said.
Yeah.
V equals IR. This is a total resistance, right?
Yep.
So, what's the I again?
That's current. That's what you're trying to get.
Oh, and then the volt is that. Okay, so, okay, I can substitute this as well. 12 V equals I. This is 6 ohms. That was horrible. Okay, even worse. So I equals 2. What's the unit for this?
Amps. A.
Is that the answer?
Well, I think so.
Good job!
Alright, so, part B. I have to rank the currents from greatest to least in all these scenarios.
Yep.
Right?
In all of the in each of the resistors.
Yeah.
What do you mean each of
Each resistor. 1, 2, 3, 4.
Wait, then why do I need this?
It's just be helpful.
Okay.
You got this!
Is it just like mathematically? You have to like write it all out.
Well, for us we wrote it all out, but as long as you can figure it out mathematically, that should be enough for the regions.
I have to rank the current. And current is, well, this is IR,
Ohm's
so
law.
this is V over R. Right?
Good job.
Yay! Alright.
This one might take the whole 20 minutes.
Yeah, I don't know where to start.
Look at each case. Are there any one of those where you could just like easily find one of them?
Well, yeah, this one. But then what do I do here when there's 2 of them? 2 resistances.
That's just a parallel circuit. You can find each one in a parallel circuit.
Oh, wait, no!
Do you remember the
I
rules?
think I know no. No, not you say that, and now I have no idea what you're talking about now.
The rules for like voltage and current and resistance in each of the parallel and series circuits.
Yeah. You just did it before.
Well, the resistance.
Yeah. Just go. Just keep going. Don't
You're confusing me.
don't mind him. Yeah, don't
Alright,
mind
so
him.
for 4, for scenario
Nope.
4, what do you mean? No, I'm
4 is just everything. It's not a single one. Okay, look at 3.
3.
Look at 3. That 10 ohm one. That's just 1 from the first case. Like, you never did anything to that one. So if you just find that one, bam, you got 1 done.
Okay, so equals 12 over total resistance, right?
Where's yours?
What?
You're trying to find the current in each one.
The current, which is. Oh wait, no, yeah, this. Okay, see, this is where I don't. Where's the eraser? Whatever. Let me see. Okay, you could at least hold me. Okay. This is why I'm confused because I is the current, right?
Mm.
And R, this is the equation for I.
Yeah.
There's no other equation, right? Okay. And R here is total resistance.
It can be, but it
Well,
can
if
also
you're
be.
solving for the total current.
But you can also just put the resistance for that resistor.
Oh, so I just do. Wait. With the explanation, what I'm getting is that I can also just do I equals 12 over 10. Well, actually no. Would that be the 10 for all of them?
in that one
Yeah.
case, you
Yeah,
get
no, so he clearly doesn't remember the rules for voltage and current in parallel
Voltage.
series.
Okay, do you remember this?
It's on the reference table, actually.
Okay, whatever. Little recap. In a parallel circuit, let's do series first. In a series circuit, every resistor has the same current,
Okay.
and every resistor has, also in a series, the voltages add to the total voltage. In a series. In a parallel, it's the opposite
Wait. So let's go back to the voltages
of a series circuit.
of a series circuit. So let's say like this, and let's say like these two. Let's say that's
Yeah.
not here.
Yeah.
What are the voltages of these two?
They add to 12.
But how do you know which is like what numbers are of each?
Why, you gotta solve for that.
Because the
How do you
currents,
solve for that?
well, the currents in series are always equal.
The current and the series are always equal, so both of those would just be equal to the total current.
Well,
That's assuming you're excluding that 10 ohm one, but you're not.
Yeah, excluding
so-
this one.
Yeah, assuming you were excluding that, the total current is equal to the current in both of those. Right, yeah.
The total.
The current of the whole circuit is equal to the current in the 10 ohm one and the 5 ohm one.
And how to find the current of this one?
It's just equal to the total.
you need to go watch the last video.
Wait, I'm actually lost here. What?
Okay, let's do this one at a time. Let's solve. You have to reset. Okay.
I don't know. I wanted to read something.
Okay.
I'll write it back up.
Resistor 1. In situation 2, you combine these two resistors, right?
Yes.
And then in situation 3, you combine these two resistors.
Yes.
So this one is still the exact same as resistor 1.
Correct.
So you can solve for this one. Look,
How?
I of 1, yeah, I resistor 1
Yeah. 1
is equal to the voltage over the resistance
Okay.
of that specific resistor. Not the total. So, looking at situation 3, that's a parallel circuit. So, in a parallel, the voltages are...
The
voltages are equal to what?
the current times.
No. Compared to the total.
Yeah, compared to the total.
Oh. Did you say the same?
Yeah. So then, in that parallel, the 10 ohm and the 15 ohm resistors each have a voltage of 12 volts, which is a total. So you can plug in 12 volts for V. And then the resistance is just the resistance of that resistor, so 10 ohms.
Okay. Oh, I can't do math. What?
You're dividing by 10.
I know. 1.2. There you go.
There you go. We got one.
Wait,
Nope.
is it still volts?
Amps.
Amps. Yeah, that's okay.
There we go. We got one. Progress.
This is
Progress.
scenario 3.
That
doesn't
That
matter.
doesn't matter.
I mean,
That's
I mean,
just resistor 1.
Yeah, resistor 1.
That's good.
Next. Okay, now in scenario 3 as well, what is the current of the 15 ohms?
So what is the current of the 15 ohms?
Mm-hmm.
Did you say it's the same thing? So no, I'm saying that's something else. That's voltage.
They either add to the total or are equal to the total. So if voltage is equal to the total, then current
is adds to.
So the current in the 10 ohm plus the current in the 15 ohm equals the total current, which we just found.
Wait, ohms? Wait, hold on.
Wait,
I didn't write the ohms
Yeah.
here.
Yeah.
Okay. I'm confusing myself.
So I do this. Hold up. This is I. So I'm finding current. Current is. Oh no, that is I. Okay. So this plus the current of this should equal 12.
Yes.
No.
No,
That's
sorry.
I mean, the current of this plus the current of this should equal 12.
Should equal 2. That's the current. 12 is the voltage,
Oh, the total current. Oh, current.
which we just found in the last part.
Okay, so the current of this resistor
Yes.
is just 2 minus 6, which would be 0.8.
Let's Progress.
Okay, this is
That's not a specific resistor.
Yeah.
That's
It's like 2 plus 3 plus 4.
No, this is just 2 plus. Oh no, yeah.
Yeah.
Okay, and then from here, I do these two. Well, wait, no, first these two.
yes. So those two are in
This-
series. The 10 and the 5.
Yeah. So. Okay. When in series, the current is equal to the total current. Okay. So this is the total current of this, right?
Yes.
Ugh. Okay, so since it's
This is the easiest one there.
oh gosh, this is lovely. Didn't make it any better, Wilmer. Okay, so this must be equal to the current, which is I of this plus the I of
No.
it. I mean, no, equal. Just I both, which is just I. Wait, so wouldn't that be both of them are also just 0.8?
Let's go! Yes!
So now we know that resistor 2 is 0.8.
And resist. Oh no, not that.
And the sum of
Yeah, some
the
of these.
sum
resistors
of
and
those
4.
two, yeah. So
Okay.
you can write I2 equals...
Okay, I can just leave this as 2 then.
Yeah.
That's 2. Now, these two. The sum of the i's of these two is equal 0.8.
Mm-hmm.
And again, I can just use this formula to find. Wait,
Okay, but
could
what
I
is-
use that?
Well,
Okay.
as long as you have the voltage going through those resistors.
Which would be kind of annoying too.
I have to find the voltage for each. Or-
I think so, yeah.
Do you?
I don't see any other way to do that.
Okay, no.
Wait, but if I don't have the. Oh, well, I mean, no. I mean, I kind of do. Wait, no, it's the other way. Voltage. Wait.
Well, you have the voltage of 2, 3, and 4 combined.
2, 3, and 4. That's resistance now. What's the voltage for 2, 3, and 4?
2, 3, and 4 is the third scenario there. That one, yeah. And
That's the resistance.
okay,
Not the
in
voltage.
in parallel, the voltages are the same everywhere.
So that's. So I can still use 12 for. Wait. We'll have to convert that from the 12, which is for this, into these two, and from these two separate to get this part to get to this.
Yes. I mean, you know what you have to do. Just do it now.
How would I do that again? Okay. Voltage 12. So 12, it's the current
There's a way.
equals 12V divided by 15 ohms, which is, what's the value? And exactly there. So what is it, 12? Wait, that's the same thing. 0.8. Is that right? Am I on the right path?
Well, I mean, yeah, we already know that that was 0.8. We found that
Yeah.
earlier.
Yeah.
So when in series,
Yeah, this is something you just gotta
Equal.
remember.
when series and series, it's equal.
What's equal?
Current?
The currents of each one is equal to the total current.
Yes.
When parallel, it's when they add up to the current, to the total.
Mm-hmm.
Okay. So this is. Wait, then why did I do that? Can I just?
I don't know why you did that. You just needed the 12 volts for the 15 ohms. And then you can split that up.
Wait for. What?
Split up the 12 volts from the 15 ohms in the third scenario into the... In the second scenario, split the voltage up to the 10 and the 5 ohms. Because those two are in series.
And how to do that?
Using Ohm's law.
Which is.
V equals IR.
So what, you want me to I equals 12V divided by what? These two added, no, it's not added up. No, yeah, would that be added up? The 1 over, no, this isn't in parallel. Just 10 plus 5.
It's your turn to go up.
How do I split this to that? For this, I mean.
By using the currents.
But that's what I'm trying to find. I
You,
have
you
the
have to
currents.
find the voltages going through them, so you can't use the 12. Well, you do use the 12, but I'm not doing a great job of explaining this.
You're really not. You lost me, honestly.
Okay, so you have the current going through the 5 ohms, right?
The current going through the 5 ohms.
That one.
Yeah.
Yes, and you have its resistance.
Yeah. Oh, idiot. Bruh. Okay, yeah. So I can't do math in my head right now. 5 times 0.8. Okay, so for this one, the voltage is 4 amps.
4 volts.
I mean, yeah.
Is that right?
Yeah.
Let me put this here.
You didn't do much work on here.
For this one. And then from there, now okay.
Okay.
So this would be no.
Okay.
Yeah, would that be the 1 over?
Take a step back. So now that you have the voltage of the 5 ohm one,
Yes.
when you go back, that 5 ohm one was resistor 3 plus resistor 4.
Yeah.
So that means the total voltage of 3 plus 4 is
No.
no.
The 3 and 4 are parallel to each other,
Yeah.
so they're gonna have the same
No.
voltage as their total, which you have their total voltage. You just found it.
So I is 1.
What? Where did you get that?
Or is it 1/2?
No.
Okay, so yeah, then they can say.
You have the voltage,
Yeah.
4 volts.
And what he just said is when in parallel, they have the same voltage as the entire.
They have the same voltage
As their
each
total.
other,
Oh.
As their total.
as their total and as each other.
So which is 2.
I don't know where you got that from, man. They have the same voltage as their specific total,
You just found their total to be 4 volts.
which means each one has a voltage of
Okay.
4 volts.
So what do I plug in here?
4 volts over.
What is their resistance?
What, 20? No, 10?
10 ohms.
Their individual resistance.
Yeah,
Yes,
okay,
10
10.
ohms.
10 ohms.
So, okay,
Can
so
you do
0.4?
that?
Yeah.
Okay.
This is amps.
Yeah.
And this is for,
3.
what are these for both?
Yeah,
Yeah.
they're both 0.4.
3 and 4. So if you were trying to rank them from greatest to least, it would
What's
be
1, 2, 3, 4.
1. No.
From greatest to
1,
least.
2, then
1
3 equals 4.
1 is greater
Oh,
than 2,
yeah.
which is greater than 3, which is equal to 4.
Whew. Damn.
Alright, part C of this last one. So, now we're. The main difference is now we've added a capacitor into the circuit, and it wants you to indicate whether this has increased, decreased, or left the resistor the same. The current of each resistor. How it's changed the current of each resistor.
And it's after it's
After-
in equilibrium.
Okay, so in a capacitor, when put into a circuit, gets charged over time. A capacitor does not have a resistance, so the current will just flow straight through it. But a capacitor can be fully charged. When it becomes fully charged, no current can flow through it. So let's say that capacitor got fully charged, you're basically just cutting off that whole section.
Okay.
It's basically just like a switch.
Okay, so that'd be. It's going this way, right?
No,
No.
positive.
Other way?
The big one, the
Is
long one
positive.
is positive, and it always starts from the positive side.
Okay, so that would be. This still gets it. This still gets it. I mean, this also gets it, but this doesn't.
Okay, so yeah. A capacitor is now added to the circuit below, resistor 4 as shown above, and the circuit is allowed to reach equilibrium.
Does it reach equilibrium?
Yeah.
Or, say it. Wait a sec.
Indicate below how this affects the circuit. Yeah, the current in each resistor.
So, I'd say this doesn't get affected.
Resistor 1.
Are you just guessing?
Yes.
That's not how you're supposed to do this. Think about it logically.
So this is after that the capacitor gets charged. So let's just start on the easy side.
Resistor 4.
If that
What
capacitor gets charged,
Well, then that's not gonna get anything. No voltage. So this would go. Resistance would go down.
Well, the current would decrease.
current, yeah. Okay, that's the easy one.
3 is this one. Wouldn't it? Wait a minute. Would this one also go down? Would this one also go down, or would it go up? Oh no, it would go up. Right? Yeah, because since I shouldn't have got that. Since they're in parallel, the voltage, current, that gets split evenly between the two. But since this one doesn't get anything, now it's all on this one.
You're cooking.
So it's gonna go up.
Mm-hmm.
2 in series. That's still the same thing, so that wouldn't change, right? Or would that? So this is it's still getting the. I mean I don't know about, I don't want to say net. Actually yeah, maybe net because this one goes down, this one goes up. The net is still 0, so wouldn't that still be the same thing going to this one?
Oh yeah, okay. Keep thinking, bozo.
No. I don't know. I'm gonna say less, but I don't know why. Or
You gotta walk them through this one.
Yeah, no, this one's a little tough. So it would be the same if the voltage didn't change. The voltage in resistor 2 is changing because resistor 3 is getting a different amount of voltage than it was before. Because, yeah, okay, so now solve for the total voltage in 2 and 3.
The total voltage in 2 and 3?
Yeah, because now you're cutting off 4. So it's gonna change.
Voltage equals I R.
We just did this, man.
You're saying voltage is okay, these two. So
The total current's changing too.
Yeah, it is.
You have to solve for the total current again.
Sorry.
Shoot.
It's less annoying a little bit this time.
It's basically just skipping a step. Just combine again. Combine the resistors again. But now that it's charged, you don't gotta worry about 4.
Wait, so
Let's do the same steps you did before.
okay, to combine these two,
No.
these two?
Yes, because the capacitor's charged. Like I said, when it's charged, you can basically just forget about that whole line. So
Oh right, yeah.
get rid of 4, basically. Well, don't get rid of it,
To
but
do that, the shoot, what do you do with the resistance? The currents though, because there's only
don't worry about that right now.
okay. So resistances is
They're all still 10 ohms.
yeah. It's just they add up. So 20.
Yes.
For 2 and 3.
Yeah.
2 and 3.
2 plus 3 is 20 ohms. Now, now to find the voltage is still 12, right?
Mm-hmm.
So it's just 12 divided by 20 to find the I.
Yeah.
I can do
It's
that.
just something.
Where's my phone? Oh, my phone. Wait, I can do that in my head.
It's pretty
0.6.
simple.
0.6, right?
Yep.
So that's that. Now, so I just find
Okay. I equals
Wait,
0.6.
0.6, yeah.
Yeah.
So then it went down. No, because that's for both of them.
Yeah.
Shoozles. How would I find it for just that one then?
For just which one?
For just 2. Or, yeah, for just 2.
Okay, well,
Oh, wait. Do I just... No.
hold on, that's... Yeah, that's not the right equation. Well, because you're plugging in the total current, but only the sum of the resistances of 2 and 3. You're including 1 for the current, but you're excluding it from the resistance.
How am I...
No.
How am I including
Yes.
1 for this?
Are you?
No, he did it a weird way.
Oh, so that's just not correct then? Or is that? Am I just stupid?
He's just freaking, that's right. No, yeah, that's right. Current is 0.6.
Oh yeah, because
You plugged it in weirdly.
You kinda
Just write I equals 0.6.
yeah,
You wrote that weirdly, I don't know.
It's because he just plugged in 12 volts
Yeah.
without saying that
Yeah.
that
I
2
know.
and 3 is parallel to 1, so it would still be 12. So no, that is
2
correct.
and 3 is parallel to 1.
When you combine them.
Oh, right. Okay, yeah.
When you
so
combine
that-
them, they become parallel.
Yeah, so
yes.
their voltage is 12. So yeah, okay.
Okay, but now that you have redraw the new circuit when you combine them too. Just always redraw it.
Yeah, definitely. I'm just getting confused now.
It's very helpful.
This is the 1.
One.
This is
2 plus 3. So now you know the
That's-
current. So in a parallel circuit, the currents. What are the currents?
The currents
Oh,
are equal to. Or is that... Let's move this shit.
Yeah,
the currents are equal to the total current. Or is it the opposite? Okay, let's go over that real quickly. Okay, for voltages in a series circuit, the resistors have the same. No, they add up to the total. Okay. What is it? Voltage. Resistors add up to total. Well, the voltage in the resistor adds up to the total.
Yeah.
And then for
Also in series, current. This is something you just gotta memorize, man.
You don't need to memorize this. It's on the research reference table.
Really?
Yeah.
Oh. Oh my god.
equal. And then for I parallel, I series. Right?
Yeah. Yes. Yes.
Okay.
Yes.
Now where were we? Here.
So you found the current for which one was that for?
2 and 3
2
combined.
and 3. So you can just put that next to it. The 0.6 next to it. And then you can find the total current too.
That's not necessary. You find the current in resistor 2 and resistor 3. You found them combined. Now find them individually.
You could also just solve for resistor 1 right now. Can you not? You can just find the total current. That's true.
Well, yeah.
Which
You
would
don't
just
have total current right now.
you can solve for it.
Well, yeah, but you said you could just find it right now.
Okay, whatever. Listen to Carter. We're going down his path. What did you want him to do?
Find the currents in each of the 2 resistors, 2 and 3.
The ones that combine into
Come on, this is really easy.
Just divide by 2. So 0.3.
They're in series.
I'm finding what again? Current?
The current.
Oh, at least voltage. Okay. So, they're equal, so it's 0.6.
Yeah. And now compare that to the original ones.
This is 2 and 3, so 2 went up. 2 went down and 3 went up.
Yes.
which you already had. Yeah. Good.
And now you just need to find the current in resistor 1.
Well, it's in series, which is equal.
Just solve for it using the new one. It's easier.
Solve for using the what?
Using the new diagram. Because that's just the parallel one.
Alright, it's
Which is
Well,
a lot
it's great.
easier to just find each individual ones. At least in my opinion. Do you agree? Yeah.
The current, which... So... The total is... Wait. The total is 0.6? No, that's for these two.
Yep.
The total, what's the total?
Look up there. The total in a parallel is the currents of the resistors added together. You can just solve for the total. Remember, the voltage is 12 volts. Just write that down.
So it's 12 equals... What's the... Okay.
Total resistance, you can solve for that too.
He doesn't even need to. He can just solve directly.
Can you?
You're just so confusing. Oh my gosh. Okay. How do I solve for the current?
Total current, I assume.
Total current.
You did this in the last one, man. Come on.
Clearly I don't remember, man.
Okay. I is equal to V over R. I mean, you should do it again just to solidify it. So I is equal to V over R, right?
Yeah.
The total voltage is 12, which we have. And then we just have to find the total resistance. How do you find the total resistance in a parallel circuit?
In parallel? Parallel?
Yes.
Total resistance then?
Yeah.
Well then... parallels.
1 over.
Trust me, I'm getting confused with all the equations.
Yeah,
That's why.
yeah.
I think it's. Yeah, I think we just need to have it in front of you.
Yeah, if you just had the, it'd be a lot easier with the reference table that has it. But total resistance in a parallel was 1 over the resistor plus 1 over the other resistor to the negative 1.
Yeah.
Okay, do it.
We're doing which ones? 1 and these two?
Yeah.
And these are just, that's not the resistance. This is 0, this is 10. And that's the current.
No, you have it. It's right above.
You just said resistances.
Yeah.
That's,
Is that not what you have written above there? What is that?
Where?
Well, that's just 2 plus 3. Never mind then. That's the combination of 2 plus 3. So those were series circuits. So you just add the resistances, and each one was 10 ohms.
so 20.
So 20.
So just,
So this would just be
what was that, 0.6 then? I think, let me just do the math.
what?
Don't. Try to remember from what I had before, the numbers I had before. So it's 1 over 10 plus 1 over 20. Oh, yeah, that's
Yeah.
not.
So minus 1.
To the negative 1.
Yeah. It's negative 1, and then this is. Oh, yeah, sure.
Multiplied by the current, which is what you're solving for.
That's R. That is 2, 1, 3 over 20, which is 20 over 3, which is what?
Where's your calculator, Ryan?
Where your mom's phone?
I can see that.
Where is?
I
no,
can
you
hear
that. Yeah.
No, I can see it.
20 over 3. 6.6 repeating. 6. Jeez. 6.6.
So yeah,
6
total
repeating.
resistance is 6.66.
Yeah.
Yeah.
And then-
Times the current V equals.
What do you mean V equals? Isn't that V?
Yeah, just write it. V equals that 6.666 times I.
So I just write this 12 divided by this equals I.
Yes.
Yeah.
Okay, why are you saying this? It's just confusing me. Okay. Or 6.6 repeating equals I, which is equal to 12 divided by 6. 1.8.
Perfect.
Roughly. So this one went up.
No.
That's the total.
That's the total, not the individual.
Not the individual. That's a total of these two.
Yes.
Now to separate this into each, I'm finding for this one.
Okay, remember, in a parallel, the currents, what? To
In
the total.
parallel, the currents are equal. No, add up.
Okay, good. So you have the current of 2 plus 3. So meaning to find the current of 1, you just...
Divide by 2. No.
What?
What are the currents of 2 and 3?
You found it. 0.6. Remember, you found it right here.
Yeah.
And you have the total, which is 1.8. So to find this one, it's just 1.8
Oh, minus 6.
minus
So it's still the
0.6.
same.
So it's 1.2. Yeah.
Or,
Yay!
or in the simpler way that you didn't need to do that, it's just 12 over 10.
Yeah.
What?
Yeah, it is.
I don't know, you said say it again?
The voltage of resistor 1 is equal to the voltage of the total, because it's in parallel. So it's just the 12 divided by its resistance, which is 10. So it's just 1.2. It's much less convoluted that way.